Okay, so I've got 3:30. I know how to say bienvenidos in Spanish. How do you say it in Catalanian? Anyone know? No? Okay. What is it? Bienvenidos.
All right.
Comme si, comme ça. Okay.
Close enough.
Welcome. Glad you guys joined us. My name's John. This is Max. We're going to be going through a workshop running through using Rook on top of bare metal. So you guys are going to have access to actual physical infrastructure. You're going to have access to two physical machines. One's a slightly smaller machine that just has a roots file system, and another one that's got a root file system along with a number of NVMe SSD drives attached to it. We're going to walk you through. Everything's available up on GitHub. You're welcome to go take the repo, clone it, welcome PRs, but there are a number of steps you're going to go through. We're going to do everything from scaling up an environment, a Rook environment, doing the basics of installing Rook. We're going to do an upgrade of Ceph within the Rook environment. We're going to do some failures. We're going to create some volume claims. We're going to actually start up an application as well. So we got quite a bit to do. We're even going to do some Prometheus and Grafana so you can monitor the environment. So we got a bunch to do. Like I said, if you don't have a laptop, no problem. Everything we're going to do, you're going to be able to watch up on the screen. If you want to run this later, please let us know. Happy to leave the infrastructure going for you. First step is up on Etherpad here, the pad.ceph.com/p/rook-workshop. That's the starting spot. So start there. It's got the link to the to the instructions as well as a list of all the environments. So please jot your name down next to it. That'll be your lab number. If for some reason you trash your lab, it doesn't work anymore, don't panic. Don't spend the time to try and fix it. Just come back, mark down that you broke that one. We'll just rebuild it, and then put your name down by another environment. Like I said, I think we got 80 environments going, so there's plenty to go around. And if you get yourself in a bind and can't figure out how to undo it, just move forward. So with that, hopefully everyone's got a lab environment. We're going to go through and start with step one. Yep, looks like. So we're going to go over to the GitHub and follow through. If you got any questions, I'm going to be walking around. Raise your hand. I'll come by. Tell me your question. I'll probably repeat the question out loud so we got it recorded as well. And most of the time, if people run into a question, everyone else has got the same question as well. So I might as well repeat it out loud, and we'll go from there. Okay. Without any further ado.
All right. Let's get started. So I'll start with the first lab. It's kind of a presentation of the environment. So like John said, we have two physical servers. One that's what we call a T1 small, another one that's a C2 medium. The first one just has a root file system, and the second one has some SSDs available that we will later on use for Blue Store OSD devices. Kind of setup of how you access the environment is we have those lab masters. You find the IP of your lab master in the Etherpad. So that's this IP over there. And from there, you have the SSH keys and the IP addresses and all the SSH configs to access your nodes that are specific to your lab. So for everybody, they are called Node 1 and Node 2. And that's configured in your SSH/config with the correct IP. So you just need to do SSH Node 1 and you can access. So let's get started and SSH to the lab master. I took lab number 1. So here's my lab master IP. So I can just do lab 1 at the IP, and then I put the password. The password is available in the Etherpad, Rook Barcelona with some caps. Barcelona. And then I arrive into the lab master.
Yeah, so the lab master is just a jump server where we've got all the SSH keys and everything so you can log into the actual individual physical infrastructure.
All right, so let's verify that you can log into your lab master And then from there, we'll verify the Ansible inventory to have a look at what the machines are. So we have this command over here, Ansible inventory list. So we can see we have node 1 and node 2 that show up into our Ansible inventory. We use the Ansible to provision all the labs, right? Then we'll use the ping module to verify that we can access all both the servers. So node 1 and node 2 are answering to ping, so we can SSH to it from our lab master. It's all good. Then we'll SSH into the node 1, and then we'll move on to the lab 2, I think. All right.
Is everyone okay just doing this basic one? Anyone need help? Or if anyone's machines don't respond or for some reason, let me know. We can get you a different environment. But all this first one is doing just verifying that you have access to the cluster that got spun up.
All right. So before we move to the Rook specific things, we're just going to do some verification of the Kubernetes setup. So we have set up already Kubernetes on those 2 machines. And what we will do in the later labs, we will set up a Rook on top. So for now, we just verify that Kubernetes is behaving correctly and all that. So we have those commands here that will install nginx deployment into Kubernetes. So we can just copy paste kubectl apply, which will download the config file and create a nginx deployment. Then we'll do a kubectl expose, which will create a Kubernetes service, which is the way to do the service discovery within Kubernetes. And from that point on, we can do kubectl get pods. We can see we have our nginx deployment pods that are up. We have 2 of them, and they are both in the ready state. So 1/1 means they are ready, and they are running right now. So that's good news. It means our Kubernetes is working just fine there. Then let's verify the networking. So we'll kubectl get services to find the IP. Need to control C first. Find the IP, the cluster IP of our nginx deployment, our nginx service. So we have the IP there. We can do a curl of that IP, and then we get some HTML blob back. So we have the load balancing working within Kubernetes. So now that we have verified that this works, and if it doesn't work on your lab, raise your hand and John will come have a look, and otherwise we just pick up another lab. Then we'll just run the delete commands to clean things up, since we don't need this nginx for Rook. This is just to test things. Right, so let's delete this as well. Now we'll kubectl get pods to verify that things are deleted. So now it's terminating state. And now it's gone. Okay, and I'll verify that the service is gone as well. So you can see that the nginx deployment service is gone, but we still have the Kubernetes service, which is the internal service discovery service for accessing the Kubernetes API. So this is normal. All right, we can move on to lab 10.
And we had one question of, can I run this on my own cluster? Yes, all these instructions are going to be on GitHub. You're welcome to run on your own infrastructure. For today, we recommend using our infrastructure because it's set up with multiple drives, so we can run multiple OSDs, and your cluster might not have as large an environment as we're making available for you today. So use the infrastructure we've given you for today, and then you're welcome at your own leisure at another time to follow through these instructions on your own infrastructure.
Yeah, if you do this on your own cluster, your drive layout may be a bit different. Here we have a mix of file store for the first server and blue store for the second server. So then you would have to adapt to your environment and your servers. All right, so now that we have verified that Kubernetes is all good, we'll start to deploy Rook. So this is the Kubernetes, like the Rook operator for Ceph. And that's just 2 commands. We have the first one here that will install the common components of Rook, things like role-based RBAC policies and things like this to make sure that Rook has the appropriate permissions to do its job. And then we have the second command, which creates the Rook pod. And then we'll be able to do a kubectl get pods watch, and we will see that currently our Rook operator pod is a container creating state. Now it's running, it's starting to create other pods, and things are starting to to happen and to bootstrap there. So let's see and wait for things to be fully running. We need everything to be in ready 1/1 state and in running status. So that means application is ready to go. Takes a few seconds or a few minutes to download the containers and start them, making sure they are healthy and ready. All right. So where are we now? Yes, all good. So you should expect to have how many pods is that? Five pods as well in ready 1.1 and running state. Right. All right, we can verify that the deployment is up. So this is the deployment resource in Kubernetes, ready state. We see one instance is up to date and one is available, which is what we expect. All right, we're good. Let's go on to the next lab, and now we'll set up a Ceph cluster. So Rook is like the control plane to be able to create Ceph clusters, which we did in just now, and now we'll create our Ceph cluster on top. We are starting with a Ceph cluster that uses just the node 1, so it will be a single node Ceph cluster, and in a later lab, we will expand our single node Ceph cluster to use a second node. So just to explain a little bit the context, we have this command here, kubectl create, which will create a Ceph cluster object, and then we can do the watch command to see what Rook is going to do. So we have at the top here we have our Ceph cluster object. We can see it's in a creating state, and it's starting to create deployments. And the first one it's going to do is the Ceph mon. So it's going to pop up 3 mons. They are called A, B, and C.
Real quick,
Yeah.
for those of us that are on the wrong side of 40, can you make the font size a little bit bigger?
The shell or the...
Probably both of them.
All right, let's see. This is easy to increase. And this... Is that... That's bigger? All right, all right. So now you have the first mon up. The second mon is created as well. So we can see them there. Creating this third mon. After that, it's going to create the manager pods. So this is all Rook doing its thing, creating the cluster with the parameters we have set for it. All right, now the manager pod. And we know that Rook is done creating this cluster once the state goes from creating to created. And that's the way Rook will tell us that, okay, I'm done with this, and this is ready to go. So we're just waiting for that to happen, basically. Right. So Rook prepared or discovered that there is one boot device that's available on the node 1, and we have configured it to use file store for that. So it's popping up OSD 0 and using that as the first OSD for the environment. And now that cluster is created, so that's good. And we can see health OK as well. So we are ready to go. We'll examine the cluster. So this is like the parameters we have set into the environment there. Yes, perfect. Created health OK. We can do ls of varlib rook. This is the location where Rook stores some persistent data, so that if you would reboot your server, the data would still be there. You have things like keyring information in there, ceph.conf, and all those things are there, and are persisted on a specific server that hosts the mons, the OSDs, and all that. All right, so are we all at created state health OK? Yeah, I see some nods. Good. Wait, let's not lock the screen. So I'll move over to lab 12. So as you can see, so far we did a lot of kubectl commands. So that's the Kubernetes control command. It's how we mainly interact with Rook. But if you want to run some, say, standard RBD or Ceph commands or Rados commands, you're going to need a container for that. That's what we call the toolbox. So we have a command for that, and we'll just do that. It's going to create a new container that includes all the Ceph tools, or CLI tools, like our RBD, Rados, and all that, and has the appropriate permissions to run any command in your Ceph cluster. So this is more for debugging purposes, or for labs like this, it's nice to be able to run whatever you want, but in production, maybe it's better to not keep this toolbox container around. Maybe you want to remove it and just create it when you need it. So let's verify that that container is ready. Yes, 1.1 ready, running. Then we'll use this command to get a terminal into that container. So we're doing a kubectl exec in interactive mode to be able to get a shell there. And to avoid confusion, we're just gonna change the prompt. The custom prompt to this Ceph toolbox. That way we know that, okay, here we're in the toolbox and we can differentiate things. So I'm gonna open another window so that I can go back to the toolbox easily later on and switch between the node 1 where we have the kubectl access and the toolbox where we have the Ceph access. All right, so I'll just create a new tab for that. So here, yes, we can run Ceph status. We see health OK as well, 3 mons called ABC. We see that there is one manager, one OSD that is up, and we have 100 gigs of raw, more or less, storage available. I think this first server is like 120 gigs boot device. We can do Ceph OSD status as well. We just have one OSD, so it's not super exciting. It's on node 1. There is 20 gigabyte used. Since we're using the file store backend there, it's counting the operating system data as used in the Ceph as well. Then we have Ceph df, Rados df, and all the commands you might be familiar with on Ceph. You can run there. All right, so I'll need to make it dark. No. Okay, so now I'm opening a second terminal, SSHing back to node 1, so through the lab master, just like we did at the beginning, right? All right, lab 14. So now that we have our Ceph cluster up, we are going to try to use it. So let's create a volume into it. And for this, in Kubernetes, it's, before creating a volume, we're going to need to create a pool first, because now we don't have a pool. If we go to the toolbox, we could do those ls pools. There is no pools. We're going to need a pool to continue. So this is what we're going to do next. We create what's in a Rook terminology is called a Ceph block pool, and that we have configured as a replicated type with a replication factor 1 for now. We'll also create a Kubernetes storage class, and that's necessary for Kubernetes to be able to use our storage later on in the RBD driver. Go ahead.
So we had one set of eagle eyes that said, hey, wait a second, I don't see the same number of containers running on my environment.
All right.
Keep in mind that there are 2 nodes in this cluster, so the scheduler might take some of the mons and put it on the second node as opposed to on the first node. So that might be why you might be seeing slightly different deployments than what you're seeing up on the screen here.
All right. So now I'll go back to the toolbox container and do Rados ls pools, and we see that now we have a pool created. So Kubernetes and Rook went to talk to Ceph and said, hey, I need a pool, replicated pool, size 1. So this is what we have done. Now let's create a volume in that pool. So we'll do what's called a persistent volume claim, which will create a persistent volume, which will create a Ceph volume RBD image into that specific pool we have just created. All right, so we have that. Then let's do RBD ls minus p. So that's list all the RBD images into a given pool. So we go back to the toolbox for that, and now we see we have a PVC created, or a volume created with this name, PVC, and then some ID. I think we can do kubectl get pv, for instance, and we see the same thing from the Kubernetes point of view, at least. So a 2 GB volume we've just created. Right. Let me see. All right, and I see like here it says you can also verify in the Ceph dashboard, but the dashboard is in the next lab, so you can ignore that step, and we'll come back to that once we install that dashboard. All right, so now we've done some CLI things, and the toolbox is nice, but you really want to have a look at the Ceph dashboard. It's new-ish, I guess. It's kind of useful to have a visual view of things. So let's. So we're gonna need to expose the dashboard so we can access it. Otherwise, by default, it's accessible only from within the cluster, and from your laptop, you're outside the cluster. So we need to do a Kubernetes service with a type node port. So this is what we've done in this lab. But in a production environment, you're going to want to enable HTTPS, have some SSL certificates, and all that stuff. So node port might not be the best choice for a production scenario, but for a lab, it's good enough. So this is what we're going to do on node 1. And then we have this snippet that just fetches the IP and the node port, which is generated randomly and tells you where you should connect. All right, so I have this address. I just copy paste that into my browser. I have an HTTPS warning. Like I said, this is self-signed certificate. So lab, do Let's Encrypt or whatever SSL provider you choose in production. And we should arrive on our own Ceph dashboard. Brilliant. This is lab 14. Well, it asks us to log in. The username is admin, and the password is randomly generated for each lab. So you need to run a specific command there that's going to fetch the random password that you have in your lab, and that will be different for everybody. So just keep me log in. All right, so now I'm in the dashboard, and this is the standard Ceph dashboard. I think was Luminous-ish released. And we can see we have 3 monitors, 1 OSD up. We have 4 objects currently. We see the row capacity with some donut diagrams. We can see the different pools we have and all that. I think we can check the images that we have as well. So we see that the volume we just created, which was a 2 GB volume, shows up in the dashboard as well. So this is nice if you want to, have a look at things. All right. Yes, we'll just keep the dashboard window open throughout the workshop because it can be nice if you want to check things, see what's going on later on. We're creating some applications and all that stuff. It's nice to have the dashboard around. And since the URL is not so easy to remember, just keep the tab open. Now that we have things up, we can just We'll start to create an application, and we took WordPress as an example. So it's a WordPress kind of blog with a MySQL database. WordPress has a volume, MySQL has another volume, and they get provisioned on Kubernetes, and we have Ceph running in the same cluster. So it's kind of a hyper-converged example. In your scenario, you might have some nodes that are dedicated to storage and some nodes that are dedicated to run containers, but here we just have 2 nodes. So we'll download the manifests first. We can have a look at them to see what's inside. So the WordPress manifest has a persistent volume claim, which is this thing here, which, how do we go down like this, right? Let's do less. Here we create a 20 GB volume, and we ask for it to be a Ceph volume. So this is the storage class we just created before. And we'll create a deployment using the WordPress image and pass the database information. I can also show the volume mount aspect. All right, and then the volume gets mounted in var HTML. So this is where the 20 gigabyte volume ends up being. And for MySQL, it's 20 gigabyte volume as well. You can see it here. That then gets mounted into varlib MySQL. So this is very standard things. Let's create our MySQL pods or deployments. Then we will create our WordPress one. We can keep an eye on the persistent volumes. Okay, I was a bit too slow, but if you're fast enough, you can see it going from pending state to bound state. So pending state is when it's just created, but not created in Rook, but not created in Ceph yet. But now it has been created in Ceph very quickly. So everything is ready to go. I can refresh the dashboard. I don't even need to refresh the dashboard. The volumes, they show up immediately. All right. Now we'll check our pods. So we have one pod for WordPress, one pod for MySQL, both ready and running. So they have their volume attached already and we're ready to go. We can check the deployments we created. So again, one deployment for WordPress, one for MySQL. This is not an HA type example, but so you have one pod for each deployment. Then we can go with the services. So we have one service for Kubernetes. Like I mentioned before, this is the Kubernetes API. This is not something we have created in this example. This is just part of how Kubernetes works. Then we have one service for the WordPress web app and another service for the MySQL database. So the WordPress web app will talk to the MySQL service, and that will allow to load balance or to have the pods move from one server to another if necessary. Say one server goes down, the pod could move to another server and keep the same service IP but a different pod IP. All right, we can go back to our toolbox, do some Rados DF, I suppose, and some RBDLS to see that, like in the dashboard, we also have our pods volumes created. We see it as well from the toolbox. We can find more information about the volumes that were created. Let's do that. And then we'll take one of the 20 gigabyte volumes. And we see that it has no snapshot currently created just today. It has layering enabled by default and 4 megs object size for the RBD volume. All right. Yes, we can check it from the dashboard as well. I did it earlier. Access the application. Yes. So now that everything looks good on the WordPress deployment, let's try to access our WordPress deployment. So we have those commands that will find the IP and the specific IP and the specific pod where your WordPress application is available. You paste that into your web browser, and then here you are. You're into WordPress. I don't know, it's Ceph con something. Ceph. Let's keep this. I don't know. Sure. And then we can go on with our WordPress install. Perfect. So just in a few commands, we get a hyper-converged deployment with Rook for storage, and then Kubernetes provides the containers for WordPress in this example. All right, so everybody reaches the WordPress setup. Yeah. Okay, now Ceph is a highly resilient system, and it's designed to manage failures very well. So let's try to simulate some failures. So we will open 2 windows here. So I will put one on the left and one on the right. Let's switch to light, like so. Let's go to node 1 as well. On this left window, we'll do watch pods. Or maybe it will be top and bottom. All right, so here we list the pods that are created by Rook. And we have this OSD 0 that is running on the node 1. Let's run a pkill -9 Ceph OSD that will kill that OSD, and we can see what happens. All right, so it's not super visible, but the restart counter went from 0 to 1. So basically, from the application's perspective, the OSD went down, and then Rook detected that something went wrong with that OSD and restarted the container because, well, it's supposed to run, right? This is a pod that is supposed to run. This is how Rook configures those things. So it monitors that they are running, and if they crash, like for whatever reason, somebody runs a pkill by accident, for instance, or Kubernetes and Rook take care of restarting it and bring it back to the expected state, which is running. So we might have our toolbox over here, Ceph status, and I'll scroll this back up, and we are still at health OK, even though we lost OSD and it came back up 1 second later. So this shows a bit the benefits of using Rook and all that. Otherwise, you would have maybe systemd or whatever process manager you have handling those things. All right, so now we'll do another type of failure. Let's imagine that we have an application level failure, so like a database failure. We will just delete the MySQL pod with this command. So we'll tell to Kubernetes this Kubernetes pod that we have created for MySQL. Let's delete it, and let's see what happens. All right, it says WordPress MySQL being deleted. The pod goes to terminating state, and then Kubernetes creates another one. So that shows a little bit the benefits of resiliency for the application as well, not just for Ceph parts.
So quick question here. So how does that impact Rook, and what does Rook need to do in case the MySQL database moves from one node to a second node?
All right. So that's an excellent question. I don't know if it was visible here, but since the database has a volume attached, like for persistency of the data, like the database has to be persisted, Rook and Kubernetes will make sure the volume moves with the pod. So if that pod or container gets scheduled onto some other server because it's more appropriate at that point in time to schedule it somewhere else into the cluster, then it will detach the volume, the RBD volume, from that first server and then attach it to the other location. So this is really like fully automated there, kind of like what you would expect in a cloud provider with block storage services, for instance. So this is really what's happening behind the scene. We can do another one, I suppose. I don't know if it will move to node 1, but node 2 as well. All right. So node 2 is much bigger than node 1, so that's probably why it's sticking to node 2. It doesn't want to go to node 1 yet. All right. So everybody got that one working with the MySQL pod coming back. All right. So we don't need to the WordPress part. This is just for the demo. So we'll just tear things down, kind of for those who are interested, you make this watch with a kubectl get PVC, which will list the persistent volumes we have created in our cluster. And then we'll run the delete commands over there. And you can see that Kubernetes detects immediately, okay, this volume is not needed anymore. We're going to terminate it. So first, we're going to stop the container. Then once the container is stopped, we're going to detach the volume. And then we're going to clean up the volume from the Ceph side and like free up the resources for somebody else to be using them. So this is done for the MySQL one and now for the WordPress one. All right. Perfect. So now WordPress is completely gone. We can verify with the dashboard. Now there's just this first 2 GB volume we created at the beginning. All right. Lab 30. All right. So Rook is very much focused on Ceph, or it's the like stable one of the first features that Rook has. It also has support for other capabilities like database provisioning. I think it has CockroachDB, which we'll demo just now. There is a Cassandra, HFS, NFS, and a couple of other features. We just don't have enough time to cover everything, so we pick CockroachDB. CockroachDB is like a distributed database, sharded across different servers, and has the same wire protocol as PostgreSQL. So most likely, so you can use any like PostgreSQL library or PostgreSQL client to connect to CockroachDB, which is kind of neat on that front. So this is like a separate operator of Rook, so it has to be installed additionally because not everybody wants everything to be installed by default. So let's copy paste this, kubectl create the CockroachDB operator. Let's watch the pod being created. Now it's running, perfect. And then let's download the CockroachDB cluster definition. Let's have a look at it. So we name it we will create a cluster that's with name Rook CockroachDB. We give it a volume template, which will use the Ceph provided storage. So CockroachDB will use storage provided by Ceph, and Rook will manage both the Ceph part and the CockroachDB part. We ask for a cluster of 3 nodes, and then we define a couple of ports for access, cache levels, and this kind of things. All right.
Another quick question for you.
Go ahead.
Can you pull open the YAML file again? So what does the access modes mean?
All right. So the access modes, you have kind of 3 choices there, and it selects the way you can, how many people can use this volume. So this one, which is read write once, is the one we've been using so far. And that means that only one container can use the volume at any point in time, it being in read or in write mode. So there is it blocks people from having 2 containers trying to write to the same volume, for instance, or one would write, one would read. So this is what read write once means. Then you have read write many, which means that any number of container could read and write to the same volume in parallel, and there is read many write once, which means one container can write to the volume and as many as you want can read the volume. Since here we're using RBD, there is the exclusive lock mechanism, which means we can use only one container at a time per volume. Go ahead.
I will say that actually some databases will let you use read write many, and then you'll corrupt your database, so don't do it.
Yeah, it's there. It might not be the great idea to use it, right? Because you can do it doesn't mean you should do it. Great tip there. All right. Got locked again. So now that we've had a look at the manifest, we can just apply it. So kubectl create the file, and then let's describe the objects we just created. So this is more like a more human readable way to display the same information as what was displayed in the YAML once it's applied. So if you're not very friendly with YAML, you have the describe command that can be useful. All right, let's do a watch. Yep. So now we see that Rook created 3 pods, 0, 1, and 2. And now they are all running and ready to go. It also created 3, it's too wide to fit in the screen, 3 volumes of 1 gigabyte each. So, and those volumes are then attached to each pod, of course. All right. Now, I said CockroachDB is like a PostgreSQL database, or PostgreSQL-like database. Let's go into one of the pods, and we'll try to run some SQL commands to kind of play a bit around with this database cluster. So similar to the toolbox, we just run a shell into it. Then I have this SQL command, so we can list the databases. Currently, there's just a system database, so let's create one which we'll call example. All right, we have created the database called example. Let's use that example database. Now we will create a table. I don't know, it's an example called customers, which has a first name, last name, and some ID. All right, we have a table where we'll insert some data in said table. Right. And now let's do a select. And we have a bunch of data in our table now. Brilliant. We can do some more complex selects. So it's CockroachDB has the full SQL specs. I don't remember which version of it, but you can do aggregation functions like count, sums, all that stuff. So it's not just a key value database, it's a full relational database. Joins are supported and all that. All right, so it's not a CockroachDB workshop, so let's exit that. What's kind of nice with CockroachDB is that it comes built in with a dashboard. So just like the Ceph dashboard, by default it's internal to the cluster only, so we need to do a node port to be able to access it from outside. So let's do that. And then we'll run the snippet that outputs the random port that we need to use. All right, over there. And now we can reach the CockroachDB console. So it lists the 3 different pods that are part of this cluster with like memory usage, different versions, which is kind of nice. You can see information about the capacity that's used in your cluster. Well, of course, this is very empty cluster. I just created 6 entries in one table, right? So it's it's kind of empty. We have some metrics. So this is like built in. It collects some metrics about SQL latencies, amount of queries that are run, memory usage, CPU usage, all that stuff. So I invite you to have a look. It replicates the data across the 3 containers, of course, and the 3 volumes. And yeah, we can see our databases. This is the system database below and the example database here with our customers inside. You can see our schema and all of that. All right. So everybody got to the CockroachDB dashboard. I see some nodding. Yeah. Cool. So let's move on to lab 40. So far we've been playing with a 2-node Kubernetes cluster, but a single-node Ceph cluster. That's not really, that's not really cool. We want to have a proper, more multi-node cluster, right? So this is lab 40. So first, let's have a look at the node 2, how it looks like. So here we do a fdisk -l, which lists all the block devices available on node 2. So we have 2 SSDs with 400 gigabytes available, and then the boot devices with 200 gigabytes available. And to compare with node 1, we see that there's just 1 device there. So let's change that. So we will do the 2-terminal thing again. All right. All right, so we can see that Rook has already created a discover pod on the second node. So we have like the first one, which is on node 1, and the second one that's on node 2. And those pods, they are there to collect information about what block devices are available on a given server. So Rook does like block device discovery in your cluster.
Another question for you.
Yeah, go ahead.
So node 1 has a block device on it. How come Rook didn't go and use that block device on node 1?
So the node 1 has 1 block device, right? But it's already formatted for the boot file system. or the root file system. So we can't really like reformat it and use it for that. So what we've done there is we've configured things to be in file store mode. If you know Rook from pre-Luminous versions, there was the file store mode, and now there's the blue store mode, which is much better in terms of performance. So here we have a bit of a mix of both. On Node 1 file store and Node 2 we will do blue store. So we can have a look at that, how we've configured this with kubectl edit Ceph cluster, which will allow us to edit our cluster. And we can see that in the node list, so nodes, there's a list which contains node 1. And for that server, we have said to use this directory, varlib rook. And when we set these directories, it means use file store. Now, let's add another node. Or let me go more here. And we will add another element to that list, and we will call it node 2. The YAML is very picky with the indentation, so be careful to have your dashes at the same level for node 1 and node 2, and make sure you have the same spaces. Then we will just go ahead and save this. All right. So this is how it looks. And then we will run the watch command, which is there. I don't know if I copied it. Right. Yes, we have the watch command. And let's put this full screen. Yeah, my screen is a bit too small. Let's see. So I'll reduce the font a little bit. All right. So, and then we can see that Rook is doing things. So we can see that our cluster is in an updating state. So it means that Rook is doing something with this cluster. And that thing that it's doing, it's currently preparing the OSDs. So we see that there is this OSD prepare-node 2 running on node 2. That is the new node we are adding to our cluster. And we are preparing those OSDs. So for Blue Store, you still need a little bit of partitioning for the RocksDB and the journals and things like this. So it prepares things there, and then it pops up the OSDs. Once they are prepared, just creates the OSD 1, OSD 2, OSD 3. So we can see them there. Good. And we can see now that our cluster is back to created health OK state. Perfect. Okay, health worn now because we just added some OSDs, so there's a little bit of rebalancing happening probably. Let's resize this down. All right. Yes, so it will run one container per new block device. Let's exit this. And so our first pool we created was replica 1. So now that we have 2 servers, let's do replica 2, right? So kubectl edit Ceph block pools. We end up in text editor again. We just say size 2 instead of size 1. We save, and that's it. Then we can go to our toolbox container, which was over there. Do a Ceph watch, and okay, we don't have so much data, right? So it's very quick to rebalance. But for a second, you could see that it was health worn, and now it's back to health OK with the degraded state being resolved. All right. So now we have done that, we can move on. So far we've played a lot with RBD, which is the block storage aspect of Ceph, with the volumes we create and all that. Now let's do some object storage, which is RGW. Right. Right. All right. So yeah. So the question for the recording is, how does it work with the different OSDs being of different sizes, right? So let's do in the Ceph toolbox CF OSD status, and we will see indeed that there is the OSD 0 that was 100 gigs, 115 gigs, and we have OSD 1 400 gigs, OSD 2 as well 400 gigs, and the third OSD 200 gigs. So the first one is on node 1, the last 3 are on node 2, right? So those OSDs should have different weights. So let's have a look at Ceph OSD 3. And so this is the tree structure of how the OSDs are organized in the Ceph tree. So we have the root, which is called default by default. Then you have one step below, you have a node. So we have host node 1. And node 1 has a leaf called OSD 0. And then node 2 has 3 leaves, OSD 1, OSD 2, OSD 3. And each of those have a weight associated to them. So you can see that node host OSD 0 has a weight of 0.13, which is more or less the amount of terabyte it has, 0 to 13 terabytes. And OSD 1 has a weight 0.4, which is 400 gigabytes more or less. And the same for OSD 2, same size, right? But OSD 3 has the weight 0.2 because it has 200 gigabytes available. So Ceph sets different weights there, and then it's in the crush algorithm, it takes into account the weights to place the data based on the weights as well, not just the locations, right? The weight can be whatever number you want. It's a float, I guess. So if you have a 4 terabyte drive, it's going to be 4. If you have a 14 terabyte drive, it's going to be 14. And then you can adjust those weights if you have some preferences and things like this. All right. So we can get going with the object storage part. So we will create, let's see, session node 1. We will create an object store, which is basically another set of pools, because in RGW you need several pools, one for metadata, one for log, one for data. And then we will watch Ceph or Rook create different things there. It takes a little bit of time. There are a bunch of pools to create, a bunch of containers to create. We create the Rados gateway pods or gateways. And there we need to be a little bit patient, right? So we have 3 Rados gateways, because in the manifest we ask for 3 gateways. So they pop up. All right. Now we can either do Rados ls pools in the toolbox. Yes, now we see my store, which is the name of our Rados gateway data store. We have the metadata, the logs, the buckets, and all that. And we can also see it in the Ceph dashboard, I think. All right, I'm logged out. Yeah. Let's see. All right, I need to find a password again. Well, it was in lab 15. We create the dashboard, I think, right? All right. So now we have all the Rados gateway pools, and there are some things that we see we don't have any users there. No, the dashboard doesn't have the object gateway configured yet. All right. So to be able to use our Rados gateway, we're going to need some users, because we want to upload some objects to it, right, and download them and create buckets and all that. So there is object store user manifest for that. So we do that. We tell to Rook to create an object, a user, and we will try to fetch the API keys associated to this newly created user. And we have an access key and a private key, or a secret key. So this is used for the S3 API access to RGW. So we have those values there. And I will install a client. Here I'm using the Minio client, which is kind of nice for accessing S3 API. So let's download that. Let's make it executable. Let's verify that it works, right? We have MC working. Then we'll need to configure the client to point to the correct endpoint, pass the API credentials to it, and we see this added my store successfully. Brilliant. All right, then next step is to do make bucket, which is abbreviated to MB, so to create a new bucket, which we will call my bucket, and you should get this bucket created successfully message. After which we will list all the buckets into my store. We can see our bucket, perfect. And we will do MCCP, which will copy data from our machine into the RGW endpoint. Here I'm just copying data from /tmp because there is a bunch of files available there. There's like a few hundred megabytes. But you could copy over whatever file you want to your RGW. And you can see that it was quite fast. All right, now let's do a list of the objects available in that bucket. And it just so happens that this is the locations where the temporary installation files for Kubernetes are located. So we just copied kubeadm, hypercube, calicoctl, and CNI plugins into RGW, but could be any file. All right, so it's nice to have a CLI access to RGW or S3 API, but we can also enable HTTP access, right? So let's do that. We're gonna enable read-only access to our bucket so that people from the internet can download objects from our bucket. So this is this policy download. Unfortunately, it says error, but it's okay. So it says error and then later okay, but it's fine. Just you should get this message. This is what's expected, 200 okay. All right, so don't be scared if you have this. And then we'll list the policies associated to our bucket, and we can see that my bucket has the policy read-only, which is fine, which is what we want. And currently our bucket is, or our RGW service is exposed only through a cluster IP, which again is internal. So we need to create a node port again to have the external access. And again, this in real life, you're going to want this to be over HTTPS with SSL encryption and all that. But here we are doing plain HTTP. And again, we will get the node port number and URL that we can use to access our bucket. So this is the one for my lab, but it's going to be different for your lab. I copy paste that in my browser. And here I get an XML output of the S3 API that lists all the objects that are available in this bucket. So if I zoom in a little, we have a calicoctl, which is available there as a file or an object. We have CNI plugins as well, hypercube, and kubeadm, the same objects as we just uploaded and listed in the CLI. And if I want to download a file, I can just append it to the URL at the top. So if I want to download a kubeadm binary, I just put that and then, okay, it downloads. All right. So now we have tested the Rados gateway, and I hope everybody gets to the point where they can access the S3 API from their laptop. Right? Can you? It's kind of noisy.
Yeah, just asking if you can see the Rados gateway demons in the dashboard. Hello?
Yeah, now
okay.
it's good.
Yes, if you can show us in the dashboard the Rados gateway demons, because I cannot see them in the
to see the Rados gateway demons, where are they, right?
Yeah.
All right, so if you scroll up, I think here we see them.
No, but in the Ceph dashboard, please.
In the Ceph dashboard, yeah, in the Ceph dashboard it's not enabled.
Okay.
One would have to enable the Rados gateway part of it.
Yeah, this one. Mm-hmm.
This looks like it's not enabled by default. So something needs to be fixed there.
Okay.
But otherwise, through kubectl, you can see the containers. So currently we have 3 instances for semi-redundancy. If you would have more than 2, like a proper cluster, it would be distributed across your nodes there.
Okay, and another question: if you do a Ceph status in the toolbox,
Mm-hmm.
could you why there is only one daemon active in the Rados gateway section?
Good question. To be checked. Maybe they all show up through the same keyring or something like this, I think.
I don't know.
Like, indeed, we see only one RGW there. Yeah. Any other question? All right. So if everybody gets to the point where they can access the S3 API, I suppose they just use the same keyring, and that's why they show up through the same identity or something like that. To be checked in with the Rook guys exactly how it works under the hood, I think. All right, so I'll move on to lab 70 then. So this is more of a freestyle. Like now you need to work a bit to create your own persistent volume claim. So let's download an example of a volume claim here, up, and then we'll edit that file. And we need to make sure to change the name. So maybe we'll call this workshop 1. We could change labels to whatever we want. We need to keep the same storage class. So this is in case you would have several Ceph clusters within one given Kubernetes cluster, or different routes into your OSD tree or Ceph tree. But currently this is just the one cluster we have. So we keep this. Read write once. So since we are using the RBD backend, we need to keep the access mode to read write once. So exclusive access to a volume per one container. And then here we can set whatever size we want. So let's put 12 gigabytes, for instance. And then we can kubectl apply -f this file. And we should get this workshop 1 or whatever name you have set created. All right, now let's list the PVCs and see if we can find our workshop 1 persistent volume claim. Yes, we see it in the default namespace, workshop 1. So it's already created in Ceph, 12 gigabyte. Good. And we might be able to see it in the block device there as well. So we should see something with 12. Yeah, 12 gigabytes. Perfect. So everything is created there. And this is like, if you would create volumes manually, this is kind of how you would go about interacting with the Rook side of things rather than interacting with the Ceph aspects like RBD create and all that. All right. So we can move on to the lab 80, I think. Yeah, are you good?
We got about 10 minutes, so I think we're okay on time.
Come again?
We have about 10 minutes, so I think we're okay on time.
Yeah?
Or 15
right.
minutes. Or 25 minutes.
Yeah, it's 35, right? All right. So Lab 80 is all about monitoring because, okay, it's fun to run Ceph, but you need to keep an eye on things, right? You don't want things to break, even though if they self-heal later on. You still want to keep an eye on your capacity to see when you need to order more stuff. You need to keep an eye on your performance. That's not going to auto-heal, right? So monitoring is super important. So this is what we cover now. And for that, we're going to use the Prometheus operator, which is basically Prometheus as a service inside Kubernetes. So kind of like Rook is Ceph as a service inside Kubernetes. Prometheus operator is Prometheus as a service inside Kubernetes. So it's a one-line installation for that operator as well. Oh, yeah. Right, so we have our operator created. And we need to wait for all the pods to go running. So there's one, and it's running, so that's good. Then we will need to create some specific things for monitoring Ceph to tell to the operator, hey, we have this Ceph thing there. Let's monitor that. And this might also be worth checking that everything is still running. Good. Now let's check that URL where Prometheus will be available. So this is the URL. I put that in my browser, and I'm able to access Prometheus. All right. It doesn't tell you so much. It's a very simple interface. Prometheus is like a time series database. It's not the place where you're intended to graph things and all that. This is more for querying the database directly. So it's not supposed to look amazing. And so there we can explore the interface, right? So we have the alerts So Prometheus, you can set alerts based on metrics to say if my metric, my storage usage is above this or that percentage, then let's trigger an alert and it will send an email or a Slack notification or whatever you want. So here we have a bunch of things that are defined, like if there is something that's near full or a node is down in your cluster, these kind of things. So everything is good in our cluster, that's nice. We can check the targets. So this is the URL where the metrics are available from within the cluster. So this basically talks to the Ceph manager and has the Prometheus module enabled in the Ceph manager to collect the metrics. And do we have any? Then just the graph aspects of it, I think. Yeah. So let's close that. So on the graphs, I can give an example of a query. Like if you would be to write a new query, you could want to know, let's increase the size there, your total usage of your Ceph cluster. So the metrics is in bytes. So to convert that to a more human readable unit, we're gonna do 1024 to the power of 3 to convert that to, that's gonna be gigabytes. Now let's execute that. And we get this reply from the server. Okay, it's an HTTP metric from this instance. So that comes from the Rook Ceph manager in the Rook Ceph namespace, and which comes from this pod and this service, and the value is 23. So we know we're using 23 gigs of our Ceph cluster. And we could, well, our Prometheus server hasn't been running for very long, so we don't have a lot of history, but now it just keeps track of this, and we have the graph over time. So you can see when it's going up or down and take the appropriate actions to buy or decommission equipment based on that. All right, so the UI is very basic. We're going to need something better than that. We're going to need Grafana. So Grafana is like a visualization tool for data. So let's install that. So we have this command there that will install the Grafana, and it's already with the service type node port, so it's already pre-configured to be externally available. Right. Let's collect the Grafana password, which is quite long. And then we might want to wait for the Grafana pods to be ready, so that's good. And we'll get the Grafana URL. I'll copy the URL in my browser. I'll copy the password as well. First load takes a few seconds. Then the username is admin, and the password you just decoded it. So put that, log in. Now I don't want to keep that. Then we'll add a data source, because by default Grafana just doesn't know about Prometheus, so we need to tell to Grafana where Prometheus is. So add data source, click on Prometheus, and then we will copy paste this, which is the internal URL of Prometheus, so that Grafana can access Prometheus from inside the cluster. So this URL will not work in your browser, but it will work for Grafana. We put that in there, save and test. All right, data source is working. That's good. Now we will go and import some dashboards. So you go over the plus at the top left corner. You just don't click on it. You just put your mouse on it, and then you go to import. And we're going to import dashboard 2842. So we paste that in. And we're going to select our data source to be Prometheus. All right, let's import that. And then we'll import the other dashboards, 5336. Again, we don't click on the thing. Yes. We select the data source, import. And the last one is 5342. So those numbers are basically just IDs of upstream Prometheus dashboards provided by Ceph project, so that you can directly use a quite nice looking dashboard out of the box without having to make it yourself, right? So we have those dashboards available, and it takes a few minutes for Prometheus to collect enough data for the graphs to show up, and in the first few minutes, it's going to say, yeah, something doesn't work because it doesn't have enough history to show the data on Grafana. So be a bit patient, and then you'll have, right now it's fine. You'll have enough data that it shows up. So it shows, this is a nice dashboard you can put in your TV at the office to monitor your clusters. It says the health state of your cluster, how many monitors you have in the current quorum, number of pools, the capacity, the used capacity, available capacity, how many OSDs are up, down, out, in, average latency, and all that stuff. So maybe we can zoom in, I don't know, last 5 minutes or something. Yes, then we see some graphs. Of course, you know, it's up to you to keep this running, and then maybe in 1 hour you have a lot more data, you create some more pods or something, and this could be more interesting. So this is the cluster dashboard. Then you have the pools dashboard. Let's put 5 minutes as well. So you can select different pools and see information, like usage information for this or that pool, how many objects, how many IOPS this or that pool have. And OSD dashboard, here you can select a specific OSD. So let's look at OSD 2. What's its utilization percentage, what's the latency, and the space situation we have there. So this is very useful complement to the Ceph dashboard. It's very focused on monitoring. You can really dig into, make custom queries, and have a historical view of things. All right, and then what do we have left? The last big one, I think, is the Ceph upgrades, because it's kind of nice to run Ceph and you have the monitoring in place and all that, but at one point you will want to upgrade, and it's really important to keep on the stable release. So not to run the old Firefly or Hammer releases that are now deprecated and don't have any backports. So with Rook makes this extremely simple. We will need 2 windows for this to show up nicely. So let me put this down. Let's see if I can bring up the other one there. All right. All right, so first I will do the watch. So yeah. Okay, maybe not. All right, let's just do the edit then. So we will do kubectl edit Ceph cluster. We go over to the spec image definition, and there we will just edit the Ceph image. So instead of saying to use version 13, we will use version 14. And it's that simple. We just save that, and now Rook will start to upgrade the cluster. So I'll try to put this in full screen. That's somewhat readable. All right, so we see that our Ceph cluster at the top is now in updating state, and Rook has started to update one of the mons. So one of the mons is already running Nautilus, because Nautilus is 14 and 13 was Mimic. So we started with a Ceph Mimic, now we already have one mon running Nautilus, and Rook will wait for that mon to be happy and healthy before upgrading the second mon, and then the third mon, and then the managers, and then the OSDs as well. So this is really like one command, kubectl edit, your cluster, you set the version you want, and Rook takes care of upgrading things in a proper fashion. So orchestration is taken care of for you. And you can do this live. You still have your CockroachDB cluster running, and it's still fine, and your clients are not impacted. So now we have our first mon in version 14. Our second mon is just being upgraded to version 14. And now our third mon is being upgraded to version 14. All right. Perfect. And then on the manager, being upgraded to version 14. So otherwise you would have to do this manually, go into the proper server and upgrade things, and it's a very tedious process. Now it's really cool that, it's taken care of for you. As a Ceph operator, it's upgrades can be a bit scary. This is really convenient. All right, now that we have the manager available and ready, I think it's gonna touch the OSDs, right? Yes, OSDs are next. Brilliant. So we have OSD 0 running version 14 now. So once it's started and ready, it's going to go on to the next OSD and the next OSD and the next OSD and the next OSD. It's fully automated upgrade, basically. So it's turning off the OSD and then turning it back on. And the status of the cluster is still health OK, so it sets the proper flag to say that, okay, this is expected to happen, and we don't trigger a rebalance every time, right? Because especially in large clusters or hard drive-based clusters, it can be super expensive or performance-wise expensive to do rebalances during upgrades, right? So this is, we're just restarting it. And you see it takes, what, I don't know, 30 seconds per OSD to upgrade. So you wouldn't have time to do a rebalance anyway. All right, so now we have what? All our OSDs look good. Right. Our Rados gateway is also running version 14 now. And we have our Ceph cluster is fully updated now. Perfect. All right. Then we can go to the toolbox. Have a look. What do we have in Ceph status? Yep, and we can check the toolbox. We have a Ceph status health OK. So that's it for the upgrade, and that's kind of the last part of the workshop, I think. Is there any questions? Did you all make it Nautilus upgrade and health OK?
So we did have one question. Can you increase the size of a volume? So what we tried to do was we updated the storage class to include an attribute that allowed it, but I'm curious if anyone has got any experience on whether or not that's possible, or how to do it.
I was just actually trying a few things, but he pointed me to look into the storage class, and the storage class has an option for allow volume expansion.
Yeah.
So once that's in, then it kind of lets you. But then, in order for the resize to happen, you have to kill the pod and make that happen. And then I was trying to kill pods and mess around with things, and it wasn't really doing it. But I'm pretty sure I just gotta identify what's Kubernetes expecting to increase the RBD image size and then reformat or XFS resize.
Yeah, exactly.
Because this is probably a very common thing that my volume's full, and
all right.
And then we have to hustle and figure out what's going on.
So for the volume expansion, there are two things that you need. Like you said, in the storage class, you need to enable it. I would have to check the doc exactly. I think it's like allow volume resize or something like this, or expansion. And also in the Kube API server, I think you need to set a flag to enable that. And we don't have that enabled in the lab. So I would it did let you. Yeah, so this is what I suspect. Like, I've done it into another cluster, not in this lab. You have to set something on the API server to enable that feature, which was flagged as beta or something like this. And then you need to set the flag on the storage class. Then you delete the pod where the volume is attached. It's going to detach the volume from that container. And then when it attaches it back, it sees that, well, this volume is bigger now. So it's going to do a file system resize, with whatever tool is applicable if you have selected the XFS or X4 or whatever. So this is going to take a little possibly a little while, and then it's going to mount the volume for that container, and then it makes it available. To be noted that this works only one way, right? You can only expand. You cannot like resize down the volumes with RBD. So some things are needed in the Kubernetes size for it to work, and we haven't covered those in the labs. Maybe it's a good addition to cover. Right, yeah, for sure. That's definitely a thing. Yeah.
So I think that's everything we got for the lab. A couple of administrative things. If you want us to keep your lab running, please on the Etherpad, put down, please keep the lab running, and send us a note. Otherwise, if you don't, we're going to go through and shut down because it's physical computers running that could be used for other things. If you got suggestions, send us a note. You know, we're planning on doing this again at the next KubeCon in San Diego. So suggestions are always helpful. Thank you for making all the way through, and thank you to our presenter for putting this all together and putting this on for us.